So let's take a look at this last example. So it says a square is drawn inside a circle so that its vertices touch the circle. If the radius of the circle is 15 centimeters, what is the perimeter of the square? So with this example, you have to have a picture to go with it. So a square is drawn inside a circle so that the vertices touch the circle. So I'm going to start by drawing a circle. And then inside of that circle, I am going to draw a square, or attempt to draw a square. Use my straight edge here so it looks decent. Well, got my vertices off a little bit. I'll go back and fix that. It's the perfectionist here that I am. Okay, so it's a little better. Let me fix these little dots that I didn't use. Okay, so we have the square that's drawn inside this circle, and we have the vertices that touch the circle. Now, the radius of the circle is 15 centimeters. So, as you know, a radius can go anywhere in the circle, and the radius goes from the center to a point on the circle. So because we're trying to figure out the perimeter of the square, I want to be very specific on where I put my radius, on where I draw the radius at that we're talking about here. So this radius, I'm going to go from the center to that point. And so that radius is 15 units long. But if I go from the center to the other point in the square and I create a diagonal in the square, notice how I've also created the diameter of the circle. And so now I know the diagonal of this square is a total length of 30 segments. Because it's a square, I have my right angle, and all sides in a square are congruent. So hey, what do you know? I have an isosceles right triangle with my 45, 45, 90 angles. So I need to figure out what this segment length is. And it's going to be the same length across the board. So I'm going to set up my ratio of my angles, 45, 45, 90. And then I'm going to set up my ratio of my sides, x, x, x times the square root of 2. So the segment that we know about is opposite of the right angle. So we know the length of the hypotenuse is 30 because 2 of the radius put together gives me the diameter of the circle, which is also the diagonal of the square. So 30 is equal to x times the square root of 2. So I need to get x by itself. So I'm going to divide both sides by the square root of 2. And you remember, we're not allowed to have a radical in the denominator. So we've got to rationalize the denominator. To do that, we're going to multiply the top and the bottom by that radical. Because again, we're not changing the value of anything. We're actually multiplying by 1. So now we get 30 times the square root of 2 on the top and then the square root of 2 times the square root of 2 in the denominator. And when I multiply a radical by itself, it's like undoing the radical, so 2 in the denominator. Reduce 30 divided by 2 is 15. So each of those lengths of the square, each of the side lengths are 15 times the square root of 2. Since all of the sides are the same and we're trying to figure out the perimeter, well, I can take 4 times 15 times the square root of 2. And 4 times 15 is 60. So my perimeter of my square is 60 times the square root of 2.